Use a change of variable. Another meaning, use the use substitution to find the following indefinite integral. Indefinite integral, integral sign, no lower, no upper limit. And then we can check the work by differentiation. The expression that we have is the quantity x squared plus x to the power 10 and multiplied by 2x plus 1 to determine the u or the new variable. Think about the expression x squared plus x to the power 10 times 2x plus 1. Which one is more complicated? Could you tell me which form is complicated? The power 10 or the 2x plus 1? The one that looks more complicated would be the power 10. That is the composite function. Okay, this part is more complicated. So we work on this one, and when you identify the complicated portion, the complicated means it's going to be a chain rule involving it. The composite function. Once you think about the composite function, identify which one is the inner function, which one is the outer function. The key concept of the U sub is to use U as the inner function for the composite function form. That's why the composite function, when you identify the inner outer, is very important. The inner part, right? So for this one, the inner is x squared plus x. That's what we're gonna use as a u variable. Excuse me. So start with letting u be x squared plus x. And then find the differential u, which is the derivative. So put the side on the side here if you are not quite comfortable with the differential yet. So start with the derivative. Derivative of x squared plus x is 2x plus 1. Therefore, the differential u is 2x plus 1 multiplied by dx. What we need differential. We don't need the derivative as a whole portion of substitution. We're gonna need u and du term. Now back to the problem here. We're gonna replace one by one, term by term, with the u and differential u or the multiple of them. What we have, the x squared plus x, that is the u term. Then we can replace this with a u, now u to the power 10 to replace the quantity to the power 10. How about the rest of them? The 2x plus 1 times dx, which is exactly the same as the du or the differential u term. Then your antiderivative becomes the antiderivative of u to the power 10 times du. Simple enough to see the power rule will be applied. So we have u to the power 11 divided by 11 plus c. Okay, and finish up the problem. Divided by 11 means multiply by 1 over 11. And what is the u quantity that we begin with? U is x squared plus x. Replace u with the x squared plus x and the whole thing raised to the power 11 and then plus c as the answer. And then we can check the solution by whether the derivative returns to be exactly the same form as the integrand or not. So find the derivative of 1 over 11 of the quantity x squared plus x to the power 11 plus c. The concept multiple 1 over 11. This part we use the chain rule. The outer is power 11, so multiply by 11 and the inner to the power 10 multiplied by the derivative of x squared plus x, which is 2x plus 1, plus the derivative of the c, which is 0. Simplify, 11 and 11 reduce. Now we have x squared plus x raised to the power 10 multiplied by 2x plus 1 as the derivative, or exactly the same as the integrand. So we get the correct answer. So far, so good. Okay. Next one, the integral of the radical tangent x secant square x dx. You can type in the chat if you would like to participate. Um, what would be the inner function that we can use as a u for this problem? Very good. So u is the tangent x because we see this at the inner part or the inner function. So u equals tangent x. So let u be tangent x, and then we're gonna add one step at a time to get into the differential u by what is the derivative of the tangent x. The derivative is secant square x. Therefore, the differential u is secant square x multiplied by dx. Okay, in the product form. Now we're gonna move on to the main part of the problem. So the side work, we're gonna keep it as a reference and bring it back into the main part to simplify the antiderivative. Now we have the integral become square root of the u. The secant square x dx is du. So far, we don't deal with the complicated term yet, but we're gonna get there eventually. And now this one is due to the power 1/2, which is the same as the earlier example or the first one. Now we have the antiderivative u to the 1/2 to be u to the 3 over 2 divided by 3 over 2 means multiply by 2 over 3 and then plus c. The last step always get back to the x expression. The u is the tangent x, sorry. So we have 2/3 multiplied by the tangent x quantity power 3 over 2 and then plus c. And check the solution. So the derivative with respect to x of 2/3 times the tangent to the tangent x to the power 3 over 2 plus c. The concept multiple 2 over 3 multiplied by the derivative using the chain rule 3 over 2 times the quantity tangent x to the power, which is reduced to be 1/2, and multiplied by the derivative of the inner function, which is secant square x. 3 and 3, 2 and 2 reduce. So now we get square root of the tangent x multiplied by secant square x. Checked. We get the right answer. And the answer is 2 over 3 times the quantity tangent x to the power 3/2 plus c. Okay. Right now, just straightforward, replace u and du into the expression. Let's do one more, and you guys tell me again what would be the change of variable u for this problem. What do you think? What would be the u for this problem? Which one is the most complicated one? The most complicated one that's considered as a composite function. And once you know which form is in a composite function form, identify the inner outer function. The inner function is the one inside or the think about when you evaluate the function, the composite function, where you're gonna put the number in first. That portion is called the inner function. Okay, for this problem, the inner function, yes, is square root x plus 1. So u is square root x plus 1, and the du, which is the derivative, multiplied by dx. So step by step, the derivative of the u with respect to x, yes, is 1/2, x to the negative 1/2. And to avoid dealing with the negative power, we write it into the positive power. This is multiply. And again, the positive power 1/2 is the same as the square root. Now it's simplified to be 1 over 2 square root x. as a derivative. Okay, as a derivative, we're gonna need the differential, not the derivative. Differential is the derivative multiplied by dx. So this is the one that we're gonna use. Right in the simplified form, because the original function, as you see, there is no negative power. It's in a radical form. We have to adjust the term to make it fit or as close as we can to the original form. Since the square root x plus 1 is the u, okay, I'm going to rewrite in the form that we can see in the better way. So square root x plus 1 quantity, power 4, multiplied by 1 over 2 square root x dx. When I separate in this form, I can see clearly where I'm going to replace the term. Okay, so for the square root x plus 1, yes, we're going to replace with the u. And this portion in green, that is the du. Then we have the integral of u to the fourth multiplied by du. Okay, next. Now everything is clean, much cleaner than original one. Use the use the power rule of the antiderivative. The power added by 1 divided by the new power and then plus c, because this is indefinite integral, or 1 over 5 times the quantity u, which is square root x plus 1 to the power of s, and then plus c as a result. And you do the same to check the answer by finding the derivative of the expression. So we can do it real quick here. So check by differentiation the d by dx of 1 over 5, the quantity square root x plus 1 to the fifth, and then plus c. And this is square root x is x to the power 1/2. Okay. Then we have 1 over 5 times 5 of the quantity to the power 4 multiplied by derivative of the inner function, which is 1 over square root x to square root x. 5 and 5, oops, 5 and 5 reduce. And then it comes up